Exact equations. The idea sounds abstract at first, but it's really just asking, is this ODE secretly the derivative of something we already know? Suppose there's a function f of x and y, a surface over the xy plane. Its total differential is df equals partial f over partial x dx plus partial f over partial y dy. If df equals 0, that means f is constant, and the curve f of xy equals c is exactly where we live. So if an ODE written as m dx plus n dy equals 0 turns out to equal df for some f, we've already solved it. The solution is just f of xy equals c. The question becomes, how do we find f? For f to exist, it must have continuous second partial derivatives. Clairaut's theorem then says the mixed partials are equal. Partial squared f over partial y partial x equals partial squared f over partial x partial y. Since m is partial f over partial x and n is partial f over partial y, this gives us the exactness test. Partial m over partial y must equal partial n over partial x. That's it. Compute those two partials. If they match, the equation is exact. So the test passed. Now we need f. Step 1. Integrate m with respect to x, treating y as a constant. That gives us f equals the integral of m dx plus some function g of y. Because when we differentiate with respect to x, any y-only function vanishes. Step 2. Differentiate this f with respect to y. The result must equal n. Step 3. Set partial f over partial y equal to n and solve for g prime of y. If it really is a function of y alone, which it must be if the test passed, integrate to get g of y. Step 4. Write down f of xy equals c. That's your solution. Let's work through it. 2xy plus 3 dx plus x squared minus 4 dy equals 0. M is 2xy plus 3. N is x squared minus 4. Check. Partial m over partial y is 2x. Partial n over partial x is also 2x. Exact. Integrate m with respect to x. X squared y plus 3x plus g of y. Differentiate with respect to y, x squared plus g prime of y. This must equal n, and in this example, n is x squared minus 4. So x squared plus g prime of y equals x squared minus 4. Therefore, g prime of y is minus 4. Integrate, g of y is minus 4y. The solution, x squared y plus 3x minus 4y equals c. Second example, y squared plus 2xy dx plus 2xy plus x squared dy equals 0. M is y squared plus 2xy. N is 2xy plus x squared. Partial m over partial y is 2y plus 2x. Partial n over partial x is also 2y plus 2x. Exact. Integrate m with respect to x. xy squared plus x squared y plus g of y. Differentiate with respect to y. 2xy plus x squared plus g prime of y, this must equal n, which is exactly 2xy plus x squared. So g prime is 0. G is just a constant, we absorb it into c. The solution, xy squared plus x squared y equals c. Here's the geometric picture. The solution, f of xy equals c, traces out level curves of the surface f, like contour lines on a topographical map. The ODE is telling you the direction you must move to stay on one of those contour lines. That's why df equals 0 along every solution. The recipe, write as m dx plus n dy. Check partial m over partial y equals partial n over partial x. Integrate m with respect to x, match with n to find g of y, write f equals c. Next, what if the test fails?